Hello everyone, welcome to Computer Vision, Zero to Production. This is one of the, I would say, end of closing videos for this series, where we're going to be discussing about Dockerization. Why is Dockerization important? Like, let's say, for example, you built an entire, let's say, as we've built this our project whereby we've tested, we got predictions and things like that. And let's say for now I'm using a MacBook, right? And someone else wants to run this on Windows. There is a chance that they come across dependency problems and being unable to run the application to some extent. So this is one of the reasons why Dockerization is important, right? So it makes it easier. Like let's take for example, right? Let's take for example, uh, we have, like, let's say this is our application. Let me undo this. So let's get a rectangle. Let's say this is, let's say we have our FastAPI application oval. Let's make this smaller. Let's say we have Rhombus. So in this instance now, let's say this is our FastAPI application whereby the circle is our FastAPI, the rhombus is our like dependencies, and let's say we still have something like, let's say, SQLite, also SQLite. So what happens is when someone wants to run this same application on their local machine or in their server, they might come across dependency problems. Like, let's say this is trying to install some libraries due to the OS mismatch. So one of the standardized ways is containerizing your application, which means we have this as our container. We put our FastAPI inside, we take our dependencies, put it inside, we take our SQLite, put it inside. So what does that mean? Every other person, as long as they can run, they have Docker installed. Let's check Docker. You need to check for, like, let's say Docker desktop. So you can install Docker for, let's say, for Mac, in Apple Silicon, Intel chip, Windows, Linux, and the likes. So when you install, you need to have it running. I already have it running here, right? So that we can confirm that I have it running, I can just run Docker. You'll see that we have a lot of options to run what we need to run. Okay, so back to this, right? What does that mean? As long as you have Docker installed, you don't have to worry about having FastAPI. You don't have to worry about installing FastAPI yourself. You don't have to worry about having SQLite. Or everything can be contained in your container, and anyone can start your application, right? So what we need for that now is we need to write a Dockerfile. So this is our Dockerfile. Let's start writing. So from Python 3.11 slim. So it's also important that we install some default libraries, right? So let's go through this. So we need to, most CV apps, right? They need system libraries like libglib, libsm6, libxrender, dev, and the likes, right? Because without these libraries, the libgl 1.0, 2.0, and the likes, the container starts, the model loads, but the first prediction crashes. Why? Because these things are important when you are running your CV model, in a container. So which is why we need to have those installed before we run our pip install requirement.txt. So touch and touch vision needs the libGL for internal operations. Pillow or Pil needs libsm6 and libxext and the likes. OpenCV also uses libgl1. And always test Docker on locally with a real image before pushing to registry, even though we are not looking into pushing into Docker registry. So let's proceed to writing our Docker file. Okay, so let's write from Python 3.11 slim. Then we install system dependencies. Install system dependencies that does not come with the base Python image. So we then have run apt-get updates and apt-get install -y. Yes, instead of having to have like an interactive interface for us to type y, which is for yes when installing, we have it there. So libglib 2.0, then libsm6, libxex t6, then libxrender dev, then libgl gl1. Then we have to remove some unneeded files. So we do rm-rf var lib, then apt lists everything in that directory. So we then create a work directory app app. Then we install requirements, copy and install requirements, and install requirements for layer caching. So we do copy requirement.txt into the work directory. Then we run pip install, no cache there, -how requirements.txt. We proceed to copy our application code. Copy application code for deployments. Should we just copy everything? We'll need a dockerignore, by the way. But let's copy what we have in our current working directory. We need to copy src into src. Or should we just copy everything? Let's copy everything and see what happens. Copy everything. Okay. So we since from there we are going to have our model weights. Let's see what happens. But let's have a dockerignore. That is important. So we expose the ports. So what port do we have this running on? Okay, 8000. Expose 8000. Again, this is the 8000 just for us to confirm. Expose 8000, and we then have a command. We can just do command. Since we have con there, we can just do Python and say main.py. Okay, so let's try something. So let's run Docker. Let's build our Docker image. Let's build a Docker image. So we then say Docker. Oh, we need a dockerignore. So that to make that fast, let's just speak to an AI model to give us a dockerignore. Give me a dockerignore for a FastAPI computer vision project. Okay, so let's get this. I also need to exclude this our cvm in our dockerignore so we don't get it copied. So cvm. Okay, so we have that. So let's build our application. Let's build our image. Docker build -c fruits API, and we had this last command so that it knows that it's our current working directory. This last how would I call it, decimal point. So we have our container building, and to make things easier, let's say you don't want to go to the process of writing docker build for build container, docker run for the image, running the image, and so on and so forth. So we can have a Makefile that will help us manage those things very well. And because we have a database that we are currently using, which is an SQLite DB, we would also need a Docker Compose to help us manage that. So let's copy this and let's go to our AI model. For speed, I have this, and this main, and this Dockerfile. Give me a Docker Compose. So my app can run with SQLite, also a Makefile. So I've built, so build container, so build image, run, so run container, start to have the compose set up, and run build and start, and also have something like run local to start up the app without any Docker, and so on, like down, like stop, down to delete the container and the volumes and things like that. Okay, so let's see what it gives us. So it gives us a Docker Compose. Since you are using SQLite, interesting, you don't need a separate database service in Docker Compose. The main thing is to persist SQLite database file with a volume so your data survives the container restarts. Interesting. So it says if we're using Postgres, right, we would need to have like a Postgres instance, a Postgres how would I say, a Postgres database image. So let's come here with our docker compose.yaml, the yml, docker compose, the yml. Okay, so we have this, and it gives us an improved Dockerfile. Okay, so okay, so let's see. It gives us that, and it also gives us our Makefile to make our life easier instead of having to habitually type a lot of those commands. Makefile. Okay, so let's go through our Makefile together. It gives us our app name, which is our CV FastAPI, a Docker Compose. It gives us a build which runs Docker build, the same command we ran here, but now the name is now CV FastAPI. So when we say run the image, right, it runs with the ports. When you see -p, which means it's running on 8000, and also export that 8000 to my host, to my hardware, or your server also 8000. It uses the environment variables in the .env, and also specified it's an SQLite database path. So we also have make stats. When you run make stats, it just combines the entire thing, so you don't have to run make build, make run. So make stop is going to stop the container. Make down is going to remove the container and subsequent volumes that are there. Make restart the entire thing. Make logs make you see the logs, and make ps make you see like a status for your Docker run, and the run local makes you run your helps you run your API without having to type main.py. Make install helps you install your requirement.txt, and make clean helps you clean your entire directory. So that is okay. Let's see how this goes. Okay, this should be done in a few minutes or in a few seconds. So again, this is just to ensure that even if we move our application from this hardware to a remote server like Etna, which we are going to be using to deploy, right, we don't need to manually set up a lot of these things. The moment we have Docker installed, we can just spin it up and start saving our models. So yeah, so in the next video we're going to be seeing how to actually use this Makefile, the interesting parts of having this in place, and also the advantages of using containerization for your application. So see you in the next video. If this reminds you of any projects you've worked on or you're working on, don't forget to drop a comment. Don't forget to also drop a like and subscribe to our channel so that you can get to know about more videos as soon as we upload them. Thank you.